Hello, my name is Victor Calata, and this is my submission for Quiz 4. So the problem we will be solving is this one right here. But before we get into that, I want to talk about machines, trusses, and frames. So a machine contains moving parts, and they are designed to transmit input forces. So in other words, it is an assembly of rigid and sturdy members capable of generating work. On the other hand, a truss is designed to support loads and consists of entirely of two force members. A frame is composed of beam members that are connected rigidly or by pins at joints. And in those cases, at least one member is a multi-force member. And a multi-force member supports three or more forces, or at least two forces and one or more couple. A two-force member is a structure that has 2 points where external forces can be applied, and they are on the same line of action. And members with pins at two ends have no other forces. So to start off, we're going to draw the free body diagram for this structure. And so when we do that, we end up with this. And there should be a force in the AX direction. However, since there are no other forces in the X direction, we can say that AX is equal to 0. So once we have AY and EY, we can say that half the load gets distributed to AY and half the load gets distributed to EY. This is because there's a high level of symmetry involved in this problem. So any force acting down upon it, half will get split off into AY and the other half will be split off to EY. So 80 plus 10 plus 10 is 100, and so 50 would go to the left, 50 would go to the right. So once we have that, we can move on to the next part, which is to make a cut. And in this case, I decided to cut this section right here. Or actually, before I even move on to that, it's also important to note that this problem has two zero force members, and they can be identified as this one right here. So we're not going to include that one in our final free body diagram, and that one as well. And this is because there are no external forces at this pin, which is perpendicular to this member. And even if it were off to the side for some reason, it can also be considered a zero force member because it has no other connection or force acting down upon it at that specific joint. All right, so moving on from that, we draw the free body diagram for only that section, and this is what we get. And so once we sum the forces in the y direction, we get 50 kilonewtons plus 3/5 of FAB, because we only care about the y component of that force, and we're gonna set that equal to 0. So once we do that, we get that force AB is equal to negative 83.33 kilonewtons. And since in these problems we assume that all the members are in tension, when we get a negative force, we just say that it is in compression. So in this case, since it's negative 83.33 kilonewtons, we can say that it is in compression. So once we have that, we can sum the forces in the x direction. And when we do this, we get 4/5 of FAB, because once again, we only care about the x component, and FAB plus FAG, which is, once we do that, we just set it equal to 0. We solve for FAG, and we get that it is 66.66 kilonewtons. And since this one is positive, we can say it is in tension. So once we solve that part, we draw the free body diagram for a section of this. So in this case, it would pass through here. And so when we do that, we still get the 50 kilonewtons going up, 10 kilonewtons going down from that reaction, from that force, I mean. And then the internal forces of this member, that member, and F, and the member BC. So once we do that, we're simply going to sum the forces in the y direction, and we get 40 kilonewtons, because 50 minus 10 going down, plus 3/5 FBC minus 3/5 BG. Once again, those are the y components of the forces, and we just set it equal to 0. So once we have done that, we are going to sum the forces in the x direction, which is where this force comes back into play from our earlier answer. Remember, that was FAG. And so we once again sum the forces in the x direction, assuming everything is in tension. And so we set up 66.66 plus 4/5 BC plus 4/5 BG, and we just set it equal to 0. So once we do that, we have enough information to solve for FBG and force BG, BC and BG. And so we can do that by putting it into the matrix and having MATLAB or some other software solve it for us. However, this is the faster method. If you did want to do it by hand, that's entirely possible. All you would have to do is solve either the top or bottom equation for one unknown, and then you're going to get that result and plug it back into another equation. That way you can solve for the one of the unknowns. And so once you do that, you can just use that answer to find the other force. Okay, so when I plugged it into MATLAB, I got that force BC is equal to -75 kilonewtons, which means it's in compression, and force BG is equal to -8.33 kilonewtons, which is also in compression. So once we have that, we move on to the last section of the truss that we need to solve for. So in that case, it would be this right here. And so I drew the free body diagram for just that section, and we get the 80 kilonewtons pushing down, and force BC and CD also moving down since we assumed it's in tension. And then that our last unknown, force CG. So once we have the free body diagram, we can come up with the equation, which in this case we wanted to sum in the y direction since force CG only acts in that direction. So we get the sum of the forces in the y direction are equal to -80 minus 3/5 FBC, and then we multiply it by 2 because, once again, due to the high level of symmetry, we can say that the force BC would be the same as the force CD. So once we have that, we do minus FCG since, again, it is acting down, and we come up with this equation. Once again, using our answer from the previous section. So once we do that, we once again set it equal to 0 and solve for FCG. And when we do that, we find that FCG is equal to 10 kilonewtons, and since it's positive, we can say it is in tension. So once we have completed that step, we ultimately know all the forces in the members, and this is what we get. And once again, there's a lot of symmetry involved in this problem, so a lot of the forces are going to be equal to each other. So FAB is equal to FED, which we solved earlier from this section. And then FAG is equal to FEG, which we solved from that very same section. FBC and FCD are the same. Those are going to be in compression. FBG and FDC, that's 8.33 kilonewtons, which is in tension. And then we also found that FBF and FDI are going to be 0 force members. So the internal forces within those members is going to be 0 kilonewtons. And then the last step we found was to find the force CG, and which we found to be 10 kilonewtons, which was in tension. So once again, that's the problem we worked on. Thank you.